Next MCQ, question number 29. The speed of the Earth's rotation about its axis is omega. Its speed is increased to x times to make the effective acceleration due to the gravity equal to 0 at the equator. Then x is around g is equal to 10 meters per second square and r is equal to 6,400 kilometers. So what is the meaning of the question that we have to see? At equator we want gravitational acceleration to be 0 and it can be made 0 by increasing the value of omega. So how many times the angular speed should be increased? So first we will write down the general equation. So the problem can be solved by two methods. First I will use method number 1. Method number 1. At latitude phi, the gravitational acceleration is g phi is equal to g minus r omega square cos square phi. This is equation capital A. Our problem is at equator, but at equator of Earth, angle of latitude phi is equal to 0 degree. Therefore, cos of phi is equal to 1. Therefore, cos square phi is equal to 1. Therefore, equation A gives G equator is equal to G minus R omega square. G minus R omega square. When omega dash is equal to x times omega, then G equator is equal to 0. Therefore, 0 is equal to G minus R times omega dash square. So we have substituted this value. So this is equation 1. So in equation 1, when x dash is omega dash is equal to x omega, then G equator becomes 0, and therefore R omega dash square is equal to G. Therefore, omega dash square is equal to G by R. G by R. Therefore, omega dash is equal to under root G by R. This is equation 2. So omega dash is equal to x omega is equal to under root G by R. Therefore, x into 2 pi upon capital T is equal to under root V by R. This is equation 2. Sorry, this is equation 3. Where problem will start where T is equal to period of rotation or spin motion of Earth about its own axis. Therefore, capital T is equal to 1 day is equal to 24 hours is equal to 24 multiplied by 60 minutes multiplied by 60 seconds is equal to 86,400 seconds. Like this. Therefore, x multiplied by 2 pi upon 86,400 is equal to under root. G is equal to 10 and this is equal to 6400 kilometer के मीटर के लिए multiplied by 1000. So this is equal to 1 upon under root 6400 multiplied by 100. So that is equal to 1 upon 80 multiplied by 10. Therefore, x is equal to this 8640 divided by 2 multiplied by 3.14 multiplied by 80 multiplied by 10. Like this. So these 2 zeros will get cancelled. So 864 upon 2 multiplied by 3.14 multiplied by 8. So 108 upon 6.28. Therefore, x is nearly 70. So this is the correct answer. X is equal to. So correct choice is C. So what is our condition? At equator, the gravitational acceleration should become 0, and it can be 0 when we can increase the omega. G is constant 9.8, R is constant 6400 km. So if we increase omega, then this R omega square minus G will become 0. So we have to find that new speed of angular speed of the Earth, so that gravitational acceleration at the equator becomes 0. Therefore, omega dash is equal to x times omega. X is greater than 1. ह्या x ची व्हॅल्यू आपल्याला काढायची आहे, approximate value. So if we put this at equator phi is equal to 0, so this will become 1. So g equator is equal to g minus r omega square. G equator becomes 0 when omega is equal to omega dash is equal to x omega. So r omega dash is equal to, so this is a simplification. So x times omega is equal to under root g by r. Omega is equal to 2 pi upon capital D. This is the original value of the angular speed of the Earth of rotation about its own axis. So period is equal to period of rotation of the Earth about its own axis, and it is equal to 1 day is equal to 24 hours is equal to this much second. So by substituting in this equation and simplifying, we get x is equal to 17. So this is one method. So when the gravitational acceleration at the equator becomes 0, then the Period of rotation of Earth T dash is equal to, it is given by this formula, and its value is 86.4 minute. And since G equator is equal to 0, the body has a feeling of weightlessness. So the G equator becomes 0, then new period is equal to this much. Therefore, since but omega dash is equal to x times omega, therefore x is equal to omega dash upon omega. This is equation 1, where omega dash is equal to angular speed of Earth when G equator is equal to 0, and omega is equal to angular speed of Earth about its own axis of rotation. Therefore, omega dash is equal to 2 pi upon T dash, 2 pi upon capital D. So this is equal to T upon T dash, T upon T dash. So T is equal to 1 day. This is equal to 86.4 minute. So 1 day is equal to 24 multiplied by 60 minute upon 86.4 minute. So both the values are in minute, and therefore x is equal to, this value is 1440 upon 86.4. So this value comes to be nearly 70. So you can take by log. And therefore C is correct. C is correct. So answer will remain the same. Only we should know this property. X is equal to 17. So remember this property. When the gravitational acceleration at the equator becomes 0, then the body at the equator has period this much, and the body has a feeling of weightlessness. So for complete weightlessness, the new period of rotation of the Earth should be equal to this much. The current period is this much, 1 day. So the period should be decreased. It means that angular speed should be increased like this. Next, question number 30. Two equal masses M and M are hung from a balance whose scale pan differ in height by h. If rho is the mean density of the Earth, then the error in the weighing is. So due to the height difference, there is an error in weighing. This is one source of error during the weighing. So we have to find the value of the error. What is the error? That we have to see. So the arrangement is like this. This is the big balance. It is supported at its center of gravity. So here there is a one pan. This is another pan. M. So this is the height difference H. So due to this height difference, what is the error? So on this pan, if the gravitational acceleration is G, then on this pen the gravitational acceleration would be equal to d dash is equal to gh. याच्यापेक्षा हे ग्रॅव्हिटेशनल ॲक्सिलरेशन कमी असणार. सो दिस gravitational force acting weight W is equal to m into g. Gravitational force acting W dash is equal to m into g dash. So there is a difference between the two gravitational forces. So let H is equal to height difference between the two pans of a balance. G is equal to gravitational acceleration on lower pan. G dash is equal to gh is equal to gravitational acceleration on upper pan. Therefore W is equal to weight or gravitational force acting on mass m put in lower pan. W dash is equal to weight or gravitational force acting on mass m put in upper pan. Therefore dW is equal to error in the measurement of weight. Since G dash is equal to GH is equal to G into bracket 1 minus 2 times H by R. Therefore G dash is less than G. Therefore W dash is less than W, and therefore error delta W is equal to W minus W dash is equal to M into G minus M into D dash is equal to M into G minus M into GH, M into G minus M into G into bracket 1 minus 2 times H by R. So M into G into bracket 1 minus 1 plus 2 times H upon R. So M into G into 2 times H by R. This is the value of the error. This is equation 2. This is equation 1. So we have to find the error like this. So this is equal to 2 times M into H upon R into G. But Gm is equal to Gr square. Therefore G is equal to Gm upon r square. Therefore, delta W is equal to 2 times mh upon r multiplied by Gm upon r square. This is equation 3. M is equal to mass of earth is equal to rho multiplied by 4/3 pi r cube. Rho is equal to density of earth. Therefore, equation 3 gives the error delta W is equal to 2 mh upon r cube, and this is equal to rho 4/3 pi r cube. So r cube will get cancelled, so this is equal to 8 pi by 3 m into h into rho. 8 pi by 3 g rho mh. G रहेगा. So error in weighing due to the height difference is equal to 8 by 3 pi g rho m into h. मासवर पण डिपेंड आहे आणि हाईट डिफरन्सवर पण डिपेंड आहे. जेवढं तुम्ही जास्त मास बे कराल तेवढी एरर पण वाढेल, जेवढा हाईट डिफरन्स वाढेल तेवढी एरर पण वाढेल. सो व्हाय द एरर ऑकर्स इन मेजरिंग द वेट, दिस इज वन ऑफ द रीजन. सो एरर एनालिसिस can be made by this method also. So question number 32. The body situated on the surface of earth at its equator become weightless when the earth has kinetic energy about. So this problem and question number 29 both are same. So again we are going to use the same condition. At latitude phi, gravitational acceleration due to earth g phi is equal to g minus r omega square cos square phi. This is equation capital P. At earth's equator, phi is equal to 0 degree. Therefore, cos of phi is equal to 1. Therefore, cos square phi is equal to 1. Therefore, g phi is equal to g minus r omega square equal to 1. A body at Earth's equator becomes weightless then g phi is equal to 0. Therefore, equation 1 gives 0 is equal to g minus r omega square. Therefore, omega square is equal to G by R. So this is the question 2. हीच value आपण यूज केलेली आहे. So I will give this part separately. So kinetic energy or rotation of Earth about its own axis passing through north and south pole is Ke is equal to 1/2 I omega square. This is equation B. Where I is equal to moment of inertia mi, moment of inertia of Earth, that is Earth म्हणजे solid sphere आहे, that is Earth solid sphere about its own axis of rotation, that is diameter. So read the sentence like this: moment of inertia of the solid sphere about its diameter, and we know this value directly. So I is equal to, for solid sphere it is equal to 2/5 mr square. This is equation 3. So put omega square here and I here. So put 2 and 3. Put 2 and 3 in equation B. So we get Ke is equal to 2/5, 1/2 multiplied by 2/5 mr square multiplied by omega square is equal to G by R. So 1 R will get cancelled. So 1/5 mg, 1 R is the remaining. So this is the kinetic energy. mg R multiplied by 1/5, mg R by 5. Therefore C is correct. Therefore C is correct. So this condition is important. The bodies at the Earth equator become weightless when the gravitational acceleration has 0 value. So put G phi is equal to 0, therefore omega square is equal to G by R. So this value we have just used here. So I will add one more point. This omega square is equal to G by R. Therefore omega is equal to under root G by R. 2 pi upon capital T is equal to under root G by R. Therefore T upon 2 pi is equal to under root R by G. So this is equal to R is equal to 6400 kilometer multiplied by meter divided by Gg available approximately 10. So this is equal to T upon 2 pi is equal to this under root is 6400 multiplied by 100. So this is equal to 80 multiplied by 10, and therefore T is equal to 2 pi multiplied by 800. So 2 multiplied by 3.142 multiplied by 800 second. So this is equal to 3.14 multiplied by 1600 second, and therefore this is equal to 3.14 multiplied by 1600 divided by 60 minute, and this is equal to 86.4 minute. आपण मग अशी व्हॅल्यू डायरेक्ट यूज केली होती तर ती या पद्धतीने डिराईव्ह करता येते. 86.4 minutes. When the period of rotation of the earth becomes 86.4 minutes, then the bodies on the earth equator becomes weightless and it will fly away from the surface of the earth. So this condition, the bodies at the earth equator become weightless, omega square is equal to g by r. So we can calculate the period. So taking square root omega is equal to under root g by r, 2 pi upon capital T is equal to under root g by r, taking reciprocal. So right hand side is substituted like this. So this is only 800. So period is equal to 2 pi multiplied by 800, but this value is in second. Now when you have to convert from second to minute, divided by 60, and therefore this answer comes to be 86.4 minute, like this. So this T is the period of rotation of the earth when the bodies at the earth equator feel the weightlessness. Next question, 33. The gravitational field due to the mass distribution is R is equal to C upon x square in x direction. Here C is a constant. Taking the gravitational potential to be 0 at infinity, the potential at x is तर पोटेन्शियलची व्हॅल्यू आपल्याला विचारली आणि ग्रॅव्हिटेशनल फील्ड इंटेन्सिटी आपल्याला दिलेली. सो द गिवन क्वांटिटी इज द लाईक दिस. I is equal to C upon x square equation 1. C is equal to constant. I is equal to gravitational field intensity at distance x from center of earth. From center of earth. From center of mass distribution. It is not a earth, there is some body like this. But I is equal to minus d divided x is equal to negative of potential gradient. Of course, in this case, this is a gravitational potential. Therefore, dV is equal to minus I into dx is equal to minus 6 x square upon dx. This is equation 1. Let V is equal to gravitational potential at distance x from center of mass distribution. Therefore, V is equal to integration of dV is equal to integration of minus C into x square dx. So this V is equal to dV and dV has value this much. Therefore, minus C into integration of dx upon x square is equal to minus C integration of x raised to minus 2 dx. So this is equal to minus C, and now the value of integration is equal to. So we are using this formula. Integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1. So if you use this value, put n is equal to minus 2. So x raised to minus 2 plus 1 upon minus 2 plus 1. So this is equal to minus C into x raised to minus 1 upon minus 1. So minus minus will get cancelled. So 1 upon x. So the gravitational potential at distance x is equal to C by x. So if we know the gravitational intensity, we can find the gravitational potential. So the correct choice is B. B is correct. So this is one method. Intensity is equal to minus dV by dx, negative of the potential gradient. This equation is correct for magnetic field, for electric field, for gravitational field. All the field obeys this relation. So here we have used the integration method. The simple method is like this: R E is equal to V by D for electric field. Electric intensity is equal to electric potential upon distance, of course in magnitude. So I is equal to V by D. Therefore V is equal to I into x. I is equal to C upon x square multiplied by x. So V is equal to C by x. Formula तो सही. So potential, gravitational potential. Therefore, the correct choice is again C. Therefore, C is correct. This is the second method, simple method. This is integration method. This is normal method. Next, question number 34. P is a point at distance r from the center of a solid sphere of radius capital R. The variation of the gravitational potential at point P, that is V, and distance r from the center of the sphere is represented by the curve. So V again R का graph आपल्याला पाहिजे. So we know that gravitational potential is negative. Therefore, all the graphs are in the fourth quadrant. Because potential is negative, it will be on the negative y-axis like this. So in this case, the situation is like this. This is a solid sphere. This is the center C. So this is the point P. It is at distance r. R is variable and this distance is capital R. Capital R is a radius. So R is equal to Cp. Capital R is equal to radius of sphere. So now, outside the sphere, we already know the potential. Case number 1 that we already know. Case number 1. When R is greater than R, then gravitational potential V is equal to minus gm upon R. This is equation capital A. The sphere के बारे में potential तो इतना nature आता आपल्याला देते हुए minus gm upon R. Now inside the sphere, this case is important. Case 2. When 0 is less than r is less than or equal to capital R. That is when the point P is inside the sphere R, on the sphere. Here the point P is outside the sphere. So outside the sphere and inside the sphere, this is the difference. So V for this range is given by, what to use this formula directly, V is equal to minus Gm upon Gm into 3r square minus r square upon 2r cube. Equation is dimensionally correct. 2r cube. So now here we will consider again two cases. When point P is at center C of the sphere, small r is equal to 0, therefore V is equal to minus Gm upon 3r square minus 0 upon 2r cube. Therefore minus Gm into bracket 3 upon 2r. So V at r is equal to 0 is equal to minus 3 by 2 Gm upon r. So this is equation 1. High conductor. When r is equal to r, that is point P on surface of Earth, V at r is equal to r is equal to, now substitute here r is equal to r, so minus Gm into 3r square minus r square upon 2r cube. So this is equal to minus Gm upon 2r square 2r cube. So this is equal to minus Gm upon r. So the values are like this. When r is equal to 0, V is equal to minus 3 by 2 Gm upon r. When 0 is less than r, less than capital R, V is equal to this value minus Gm 3r square minus r square upon 2 times r cube. When r is equal to r, V is equal to minus Gm upon r. When r is greater than r, V is equal to minus GM1. So these are the 4 points. So the nature of the graph is like this. So this is the origin 0, 0. This is the potential minus V, and this is the distance. So R is equal to 0, V is equal to this. This is the point A point, minus 3 by 2 minus 3 by 2 GM upon R. Then R is equal to capital R, V is equal to minus GM upon R. So this is point B. This is point B. Point B. So for R less than R, the potential increases like this. Zero is less than R less than R. And for R greater than R, like this. So this is the nature of the graph, and therefore the correct choice is C. C is correct. The variation of the gravitational potential is like this. When R is equal to R on the surface of the earth, it is equal to minus GM upon R. Then above the surface of the earth, this R is greater than R, then in that case this is equal to minus GM upon R. So it will be more than this value, and this is at center of the earth, on the surface of the earth, and this potential increases like this, non-linearly. It is a non-linear variation like this. So we should know at least the nature of the change in the potential. So potential increases like this, then again it increases. So as distance from the center of the earth increases, potential increases, but it is not a linear variation. It is non-linear variation continuously like this. So for that purpose, this equation is important. V potential at distance R is given by. So this relation is important. Like this. Okay, we will stop here. We will see the remaining question in the next session.